Welcome to Fun Facts Online. Deep beneath the waves, in the vast, dark expanse of our oceans, a conversation has been going on for millions of years. It's a language not of words, but of clicks, whistles, and haunting songs. This is the world of cetaceans, whales, dolphins, and porpoises, and their intricate vocalizations, a cetacean code that we are only now beginning to decipher. For these marine mammals, sound isn't just for talking. It's the very fabric of their society, their map in the dark, and the key to their survival. In an environment where light fades quickly, sound reigns supreme. It travels about 3 times faster in water than in air, allowing whales to communicate across entire ocean basins. This reliance on acoustics has driven the evolution of some of the most sophisticated vocal abilities on the planet. Today, thanks to breakthroughs in artificial intelligence, we are moving beyond just listening. We are starting to understand. This is the story of how we're cracking the cetacean code. To understand how whales talk, we first need to look at the incredible biological engineering that makes it all possible. Their vocal anatomy is fundamentally different from ours. We use vocal cords in our larynx, but whales have evolved unique structures for their aquatic lives. The 2 major groups, toothed whales and baleen whales, have even developed entirely distinct methods. Let's start with the toothed whales, or Odontoceti. This group includes dolphins, orcas, and sperm whales. They are the masters of high-frequency clicks and whistles. They don't have a larynx like we do. Instead, they generate sound by forcing air through a set of specialized tissues called phonic lips, located in their nasal passages right below the blowhole. As air shuffles between internal air sacs, these phonic lips vibrate, creating sound. But producing the sound is only half the battle. They need to aim it. This is where a fatty organ in their forehead, called the melon, comes in. The melon acts as a biological acoustic lens. It shapes and focuses the sound waves into a beam, which is absolutely critical for their superpower: echolocation. Echolocation is nature's sonar. The whale emits a series of clicks and then listens for the returning echoes to build a detailed acoustic picture of its surroundings. It allows them to navigate in total darkness, hunt for nimble fish, and identify objects, obstacles, and other animals. The way they hear is also unique. The returning sound waves aren't picked up by an outer ear. Instead, they travel through a fat-filled channel in the whale's lower jaw, which transmits the vibrations directly to the inner ear. It's a beautifully efficient system. Beyond the functional clicks of echolocation, toothed whales produce a rich variety of whistles and pulsed calls for social communication. These are the sounds that hold their pods together, helping to maintain social bonds, coordinate hunts, and signal emotional states. Famously, some species like bottlenose dolphins develop signature whistles. Each dolphin has a unique whistle that acts just like a name, allowing them to call out to and identify specific individuals. Now, let's turn to the other group, the baleen whales, or Mystaceti. These are the giants of the sea, like the blue whale, the humpback whale, and the right whale. They are famous for their deep, low-frequency moans and incredibly complex songs. Unlike their toothed cousins, baleen whales do use their larynx to produce sound. But it's still not the same as ours. They have a U-shaped ridge of tissue at the top of their larynx. It's the vibration of this structure, as air passes over it, that generates their profoundly powerful vocalizations. One of the most ingenious adaptations of baleen whales is their ability to recycle air for sound production. This allows them to sing their long, elaborate songs for extended periods without needing to surface for a breath. The low frequency of their sounds is also incredibly important. These long wavelengths suffer less attenuation in water and can travel for hundreds, sometimes even thousands of miles. This enables communication on a scale that is almost unimaginable to us, connecting whales across vast stretches of ocean. The most famous of all these vocalizations are the songs of the humpback whale. These aren't just random noises. They are complex, structured, and culturally transmitted compositions that are among the most sophisticated displays in the entire animal kingdom. So, what are they actually saying? Scientists categorize whale vocalizations into several main types, each giving us a clue about the whale's intentions. For toothed whales, clicks are the foundation of echolocation. The rate of these clicks can tell you a lot about what the whale is doing. A slow, steady click, click, click might mean the whale is scanning a wide area. But as it closes in on prey, that can accelerate into a rapid buzz, a near continuous stream of sound that gives it real-time information on the prey's every move. Clicks aren't just for navigation, though. For sperm whales, clicks are arranged into rhythmic, stereotyped patterns called codas. These codas are their primary form of social communication, used to share information within their tight-knit family groups. We used to think of these as simple signals, but we'll see in a moment how recent discoveries have completely changed that view. Whistles and pulsed calls are the social glue of cetacean society. These more tonal, melodic sounds are used for conversations within a pod. A rapid series of high-pitched whistles might signal excitement or alarm. Slower, lower-frequency pulses could be used to coordinate group movements. In killer whales, or orcas, these calls form distinct dialects unique to specific pods or clans. These dialects are passed down through generations, acting as a cultural marker. A young orca must learn the local dialect to fit in, highlighting the complex social learning that takes place. Then there are the enigmatic songs of the humpback whale. These are structured hierarchically, much like human music. Individual sounds are combined into phrases. Phrases are repeated to create themes, and multiple themes are arranged in a specific order to form a complete song. What's fascinating is that all males in a single population sing the same song during a breeding season. But the song constantly evolves. New elements are added, old ones are modified, and these changes spread through the entire population. It's a clear example of large-scale cultural evolution. The primary purpose is thought to be related to mating, with the complexity of a male's song signaling his fitness to females. But it may also be a way for males to interact with each other, perhaps to establish dominance or maintain spacing. For centuries, these sounds were a deep mystery. But today, we are in a new era of discovery, driven by technology. The workhorse of this research is the hydrophone, an underwater microphone. Scientists deploy arrays of them to triangulate a whale's position and link specific sounds to specific behaviors. But the real game changer has been the fusion of this data with artificial intelligence. We now collect thousands of hours of recordings, far too much for any human to analyze manually. So researchers are using deep learning models to automatically detect and classify whale calls. These AI tools can spot patterns and structures that the human ear would miss, dramatically accelerating the pace of discovery. This brings us to one of the most ambitious scientific endeavors of our time, Project CT, the Cetacean Translation Initiative. This interdisciplinary team of scientists is trying to do something once thought impossible: decode the communication of sperm whales. And in 2024, they announced a landmark breakthrough. By analyzing a huge dataset of sperm whale codas, they discovered a level of complexity that was previously unimaginable. They identified what they call a sperm whale phonetic alphabet. They found that sperm whales combine different elements, which they labeled rhythm, tempo, rubato for tempo changes, and ornamentation for extra clicks, in a structured, combinatorial way. This is a huge deal. The ability to combine a finite set of basic sounds to create a vast number of distinct messages is a key feature of human language, known as duality of patterning. This discovery suggests sperm whale communication is far more intricate than a simple set of predefined signals, They have the building blocks of a true language. We haven't translated the meaning yet, but we've found the grammar and the alphabet. The goal of Project CTI is to collect billions of these vocalizations and match them with behavioral data, hoping that AI models can finally learn what the whales are saying. As we get closer to understanding this ancient language, we are also realizing the immense threat it faces. The world of whales is being shattered by noise. Our oceans are becoming a deafeningly loud place. The constant low-frequency hum of thousands of container ships, the explosive blasts from seismic surveys for oil and gas, and the piercing pings of military sonar are creating a constant cacophony. This noise pollution masks the calls of whales, making it harder for them to communicate, find mates, navigate, and hunt. Imagine trying to have a whispered conversation at a loud rock concert. That is the daily reality for many whales. Studies show that whales are trying to adapt. They are calling louder, changing the frequency of their calls, essentially shouting to be heard over the din. But there's a limit to how much they can compensate. Before the industrial age, a fin whale's call could travel across an entire ocean. Today, that range is reduced to a tiny fraction of what it once was. This acoustic fragmentation is breaking up their habitats and threatening the very social cohesion that is essential for their survival. The journey to decode the cetacean code is just beginning, but it's already revolutionizing our understanding of intelligence. The discovery of a potential phonetic alphabet in sperm whales challenges our long-held assumption that complex combinatorial communication is unique to humans. It opens the tantalizing possibility that one day we might have a rudimentary conversation with another species. Understanding what whales are saying is more than a scientific curiosity. It's a vital tool for conservation. If we can understand what is important to them, we can design more effective strategies to protect them from the impacts of our activities. As we continue to listen with our increasingly sophisticated tools, we are eavesdropping on a conversation that has been going on for millennia. The cetacean code is a testament to the power of evolution and the diverse forms that intelligence can take. Cracking it would be one of the greatest achievements in human history, a moment when we finally begin to understand the other intelligent minds with whom we share this planet. The whales are talking. The question is, are we ready to listen?